Everyone knows the situation. You stop at a red light at an intersection and think, no one's driving the other way. Why can't I get a green light? You can't because it's a very primitive system that determines when it changes from green in one direction to the other. In many intersections there are fixed green periods regardless of whether there are cars or not. Researchers from Aalborg University in Denmark have done something about it. Through an interdisciplinary cooperation between traffic engineers and computer scientists, they have developed a method that is far more effective than the current methods.
So in principle what we are doing is that we play game with traffic. Okay, you can think of playing a game of chess, and there you would try to think ahead a number of steps to find out what is your best option in a given configuration. That's precisely what we are doing. We're sort of playing against the traffic, trying to figure out what's the best setting of the traffic light. And we keep on doing that, given the actual traffic as it happens. And UPPAAL is really a tool that is allow you to analyze and synthesize controllers in real-time settings. Of course, in traffic you have real-time. I mean, you need minimum time separation between phases.
Here is a simulation of traffic, applying traditional traffic management on the left and with the new method on the right. Notice how the queues with traditional management are much longer than with the new method. Follow the blue car with the red ring in both simulations and note how the car is coming much faster through the intersection with the new method.
So in some sense the technology behind the invention is what people call, or what we call, machine learning. It's a very much popular term these days. You talk about algorithms. I mean, you have algorithms that learn about your behavior as a person, but now we are using these techniques to learn about the behavior of traffic. But that said, of course, we also want to have absolute guarantees. I mean, we don't want to have, green in conflicting directions, and we want to respect certain timing constraints. So it's a mixture of machine learning where we try to optimize as much as we can while still offering absolute safety guarantees. So it's a merger of two different technologies. Of course, it's nice to think about the consequences for traffic in Denmark, but I think we like to think that it could have a huge impact worldwide. So all these intersections will be equipped with radars, so we will have much more information. And it really is like a disruptive way of upgrading the way you control traffic, with dramatic consequences for actually reducing waiting time and CO2 emission. I mean, it's not just a small amount, it's a huge amount. It can be hard to really imagine what could be the consequences, but I think from what we have seen in our, I would say, very real simulations, I mean, they will be quite substantial. So we have concrete plans with municipalities both in Aalborg and in Aarhus. So I would say if you hit the right intersection, you should be able to see it somewhere in the autumn in either of these cities. The next obvious step in this process is to have our controller really being evaluated in these selected intersections in Aarhus and in Aalborg.
Looking at the difference throughout the morning rush hour, motorists save 53% in driving time compared to today's situation. Queues are 64% shorter and there are 21% less stops. Finally, 28% of the fuel is saved.